Hello and welcome back to the lecture of time series econometrics. In this lecture, we are going to solve some problems from AR and MA model. So our first problem is as follows. Suppose we have a MA2 model and we need to get some idea about the ACF from the plotting of YT and YT minus 3. Now, if you know about MA2 process and the way it works, just by looking at this question, you will have a clear answer to it. So what happens is, in MA2 process, you really have the covariance up to lag 2. So the moment you say you want to get any sort of relationship between yt and yt minus 3, where yt minus 3 is basically the value of the time series at lag 3, so there is no question of any correlation at all. So it will give you zero correlation basically. So then it is going to, your answer is going to be zero, the ACF is going to be 0. So if you just plot it, you will have something like no correlation. So if you plot yt here and yt minus 3, you are going to have no correlation. Okay, let us look at another problem. Find the correlation coefficient between yt and yt minus 2 in a MA1 process if theta equal to 0.9. Now, the major thing that we need to focus is the order of the process. When we are talking about a MA1 process, then we know for MA process it is always the correlation coefficient you can only get up to the number of orders you're considering. So basically you can say it has to be, the order has to be greater than equal to lag, right? So whereas your order is this and your lag is this. So if you have a lag 2, you're basically taking correlation between yt and yt minus 2, which is a time series value at lag 2, whereas your process is a lag, order 1 process. So in this case again you will see the same thing, there will be no correlation, and this value of theta, it is given just to confuse you. So what will happen here, you are going to see the same sort of relationship. Here you have yt and yt minus 2, right? So you will have no correlation. But if I would have asked you yt minus 1, then you could get a value of the ACF using the value of theta. Okay. Now let us look at another problem. This is a problem where I'm talking about a MA6 model. So that's a like pretty high order model with theta 1 equal to 0.5, theta 2 equal to minus 0.25, theta 3 equal to 0.125, theta 4 equal to 0.0625, theta 5 equal to 0.03125, theta 6 equal to minus, here we have a minus 0.015625. So here we have a minus. This value theta 4 is also a minus, right? So find the equivalent phi in a AR1 model. So that's a very interesting question actually. How do we think of a MA model as an equivalent AR model? So we know, we have already learned the concept, and what is the concept called? Concept is called invertibility principle, right? We use the principle of invertibility when we convert a AR series into a MA series or a MA series into a AR series. So let me write down the principle of invertibility, right? So that's what we use for the conversion, invertibility. All right, so let me now write down the MA series of order 6. So I will write it as yt is equal to et minus theta 1 et minus 1, theta 2 et minus 2, theta 3 et minus 3, theta 4 et minus 4, minus theta 5 et minus 5 minus theta 6 et minus 6, right? So that's what you get here. Now let us put the values here. I have theta 1 is 0.5, so et minus 0.5, et minus 1, minus of 0.25, et minus 2, minus of 0, 6 to 5 into, let me write down, 80 minus 4, right? 80 minus 4. Then I have minus of 0 0.03125, 80 minus 6, 80 minus 5, and then I have minus of 15625, 80 minus 6, right? So that's what I get here. Now let me further simplify this. And what I can get here is, now I can write it as 80 plus, so my theta value, I'm just trying to get my theta value here, 0.5, 80 minus 1, then I can write it is basically becoming plus of minus 0.5 square, right? 80 minus 2, then I can write plus of minus 0.5 cube, 80 minus 3, right? 80 minus 3, then I'll have minus of 0.5 to the 4, 80 minus 4, I think, yeah, that's right, and then I'll have minus of 0.5 to the 5, and let me take it here, 80 minus 5, okay, and then I'll have my 80 minus 6 term. So given this expression, I can very well write this equation. Let me now go back to my yt. Yt is going to be, so I got my infinite GP series, right? So that's what I was looking for. So I got my theta square value. My theta here is minus a 0.5, minus a 0.5, right? So I can write, so if I use a lag expression here, this expression would be it 1 plus theta L plus theta square L square, theta cube L cube, and so on, right? So now if I use the GP formula, I get et by 1 minus theta L. So that's basically what I get here. Now just I'll write it in this space. I'll use a different color now. So I can now write my yt into 1 minus theta L is my et, right? So which means my yt minus theta yt minus 1 is my et, right? Which means my yt equal to theta yt minus 1 plus et. This is exactly the expression for AR1 series. This is exactly the expression for AR1 series. So let me write down. So this is my, okay, I'll write it separately here. This is the expression for, this is the expression for AR1 series with phi is nothing but equal to theta equal to what? My theta is minus of 0.5. So that is the answer. So that is AR1 series with a phi value of minus of 0.5.